Hi, I'm Christina Tank, an assistant professor here at Iowa State in science education. Today we're going to talk about some of the content and processes for teaching science. So as you can see what's on the screen here, in August, the State Department of Education adopted new science standards in the state of Iowa. And these science standards are based on standards that were put out by a national organization called the Next Generation Science Standards. So as you can see, that the Iowa core are a modification of these next generation science standards. So within these next generation science standards, there are kind of these topic arrangements for how they would see kind of different units at different grade levels. So you can see for kindergarten, for example, they look at forces and interactions, ecosystems, and weather and climate. So within those are some bigger topics, and you'll notice those are pulled out of different areas. So physical science, life science, and earth and space science. Along with these different topics, they have these storylines. These are kind of an overview for what is expected for kindergartners to learn in these different areas. And so they have kind of these guiding questions that will help you to think about what these units might look like and what students might learn within these different units. So as part of those, like I said, there were kind of three big topics, and they fall into different content areas. So within science, you are expected to teach physical science, which includes both chemistry and physics, as well as life science, which will pull in some biology, some ecology, some environmental science, and then earth and space science, which will do some geology, some other environmental science, and astronomy, those type of areas. So there's a lot within our science content that we're expected to teach as elementary teachers. And you can see that also what's exciting with the next generation science standards is that the science content spirals. So students might learn about matter at a level that's appropriate for them in kindergarten, then they'll revisit it in third grade, revisit it in middle school, and again in high school. So these topics aren't just you learn them once and you're expected to know it. So here is an example of what the next generation science standards look like, and Iowa adopted just the top part, these performance expectations. So those are kind of what they hope students can do within science. Along with those, though, come three different areas. So one of the ones when we start to think about how you teach science are these practices. So getting students to think about what scientists and engineers do as they're doing science or engineering, and having students model and engage in some of those practices. So an example would be asking questions. So that's based on what they want to find out, what they want to know, and then how do you investigate that for the different practices. So you can see this is a picture of the different practices that fall within kind of that blue box. It's called kind of dimension 1. So they're asking questions, they're developing models, they're planning and carrying out investigations. So a lot of what they're doing, right? A lot of hands-on, we call it kind of inquiry, engaging, exploring. They're analyzing and interpreting data. They're using different areas, mathematics and computational thinking. They're constructing explanations. And then when we get into engineering, we'll talk about in a second, but they're also designing solutions. So these problems that they're solving in engineering, they're also designing their own solutions. Or they're thinking about what explanations, what evidence, what am I learning about the science? And then also just thinking about how they obtain, evaluate, and communicate information. So is all the information I'm getting believable, valid? Do I need to do it again? Are people making this up, right? Different things you want students to think about to be kind of good consumers of science and good citizens. So as we think about this, how to teach science, what we use is the 5E model. So let's get to this idea of inquiry. And there's different representations for the 5E model. There's multiple ways to kind of think of it, whether it's a line or a circle or kind of a spiral, but similar steps, right? So you're engaging the students, you're hooking them, you're exciting them about what they're going to learn. Then from that, you're giving them a chance to explore this question that you posed, or this problem that they're solving. So they're getting to kind of go in and construct their own understanding about these different ideas, right? And kind of come to some of their ideas, get at maybe some of their misconceptions they had or what they don't know. And then the really important part is after they've been able to explore with their hands-on ideas, then the teacher comes in and helps students make sense of it. And that's kind of the explain step. And so students aren't walking away with misconceptions or ideas that they don't know, but the teacher kind of comes in and helps to provide some of that information. And then you kind of extend it in the elaborate phase. So then they're thinking about, okay, now I have this idea, the teacher told me these concepts, what does that mean? Or how do I apply it? Or what does this look like in a different setting? And then evaluating, just making sure that they learned the science content you wanted them to take away. And if not, then you go back and engage them again. So kind of this cycle of learning where the teacher is really more facilitating, the students are kind of hands-on exploring their own ideas and constructing their ideas. And so the teacher more as facilitator than teacher as kind of delivering it. Another exciting part of science that I wanted to make sure I touched on was this idea of engineering. So with the next generation science standards, and a lot of states are doing this on their own too, there's addition of engineering. And so they banned it so that K2 is doing kind of their version of what's appropriate for engineering, and these are practices and content. And then you'll see it again in 3-5, and then in middle school and then high school. So that's spiraling that I talked about earlier. And so with engineering, it's really exciting because that provides kind of a context, this interdisciplinary nature of engineering, to bring in some of the other STEM subjects. So some science, some technology, some engineering, some mathematics, and even other areas. You can bring in literacy, reading and writing. And that's one of the things to really highlight in science, because there's a reality that in this table, that science just isn't taught a lot. So you can see in this table, it was asking elementary teachers how often they teach these different subjects. So 99% of them said they teach math all day, most days, every week. Whereas only 20% of the teachers said they teach science in K3. In 4-6, a little bit more, 35%. But what's interesting is looking at teachers who teach it some weeks, but not every week. So 41% of the teachers, almost half of the teachers, said they only teach science some weeks. And then when you look at the number of minutes spent, if you look at science, on average, it's 19 or 24 minutes taught in these subjects. So not a lot of time. So it's really important that the science that we're doing is meaningful and hands-on, because as we talk about STEM and the importance of STEM and students engaging in STEM, careers, fields, knowledge, this starts early. It starts elementary. It starts before elementary, engaging them in some of these things, and science is a huge part of that. And so thinking about not only that content of what you're teaching, but how they're teaching it is really important as well.